Okay. Okay, so now we want to look at how do we find the derivative of the inverse function? Okay, so now some of these actually are rather easy to find. And some of them are not. Okay, why are my notes not doing this? Okay. So the goal of this section is to calculate the derivative of inverse function and recognize the derivatives of inverse trig functions, okay? So here's an example. Something very easy. So f of x is equal to 1/2 x plus 1, and f inverse of x is equal to 2x minus 2. You can find that. So now if I take the derivative of f, I get 1/2. And then if I take the derivative of f inverse of x, that's a better way of writing it, I just get 2. So notice they're inverses of each other. So the derivative of the inverse functions are inverse derivatives of each other. Okay, so we have a theorem. It's a little bit more detailed than that. So if f is differentiable, D, I, F, F, B, L, differentiable, is a differentiable function at every point of I of an interval I and the derivative of f with respect to x is never 0. On I, which is my interval, then f inverse of x is also differentiable. Okay. So this is how we're going to figure it out. It's actually a little tricky, but I'm going to draw a picture first. So over here is a point A. Okay. And then over here is f of A. So f takes A to f of A. This is f. And as we know, f inverse takes f of A. Oh, f inverse takes f of A back to A. Okay. So now over here, I can find f prime at A. And over here, what I want to find is the derivative with respect to x of F inverse of F of A. Okay. So the way we do this is, let's say I have a picture that looks like this. Here is F of A. Here's F. F goes like that. And F inverse goes like this. So here's a point, and this point is A, F of A. And the point that is on the inverse function is F of A, A. That's what's on the inverse function. So the point on the function is A, F of A, and the point on the inverse function is F of A, A. So now here's the slope at this point. And then here is the slope at this point. Okay. So let's say that the slope at F of A, the slope at the point A, F of A, is equal to 3/2. Then the slope at F of A, will be 2/3. All right, so here's our formula in order to figure it out. You will need to know this. This will be on the test. This will be on the final. So the derivative with respect to X of F inverse of X evaluated at F of A is 1 over the derivative with respect to X of F of X evaluated at A. All right, so let's do this real easy. All right, so let's take F of X equal to X squared, where X is greater than or equal to 0. So we're only taking that right half, okay? We already found the inverse function. We know that the inverse function of X is X to the 1/2. So now the point two, 4 is on the curve of F of X. And the point 4, 2 is on the curve of f inverse of x. So here's the question. Find the derivative with respect to x of f inverse at 2. Well, that's going to be 1 over the derivative with respect to x of f. This one should be a 4. Because f inverse has 4, and this one should be a 2. Okay. So let's check. So I want to find the derivative with respect to x of f inverse of 4. Well, it says find f prime of x. Well, f prime of x is 2x. Then take f prime of 2. That's 2 times 2 equals 4. So therefore, the derivative with respect to x of f inverse at 4 is 1 over 4. And I didn't even have to find f. So I didn't even find the derivative of f inverse. Okay, so note, I never found the derivative with respect to x of f inverse of x, because if f inverse of x could be pretty nasty. Okay, so here's my pretty nasty example.
Professor, I'm confused.
Okay,
So could you mind going up just a little bit?
no problem.
So you have the derivative of the inverse of inverse of f of 4.
Right.
You said find, this is the derivative of x. F of x equals
So
x.
I want to find, so let me show you the next example. It'll make a little bit more sense. Okay, that one's a hard one because there are so many 2s and
Yeah.
4s floating around. Let me show you this one. So here's the example. I give you that f of x is equal to x to the 5th plus 3. Okay. So now I want you to find the derivative with respect to x of the inverse function evaluated at 4. Okay, so here we go. So the point 1, 4 is on f of x. So in order to find the derivative of the inverse at 4, because remember the inverse, so f works, the point 1, 4 is on f, the point 4, 1 is on the inverse. So I want to know what's the slope. So here's my picture. Okay, so I have some function and I have a point 1, 4, 1, 1, 2, 3, 4. So this point right here is on F. And then so this is on F. And then the point on F inverse is 4, 1, 1, 2, 3, 4. So this point is on F inverse. So this is on F inverse. and the black point is on F. And I'm asking you for the slope at this point, 4, 1. This is the 0.14. So if I'm asking you for the derivative of F inverse of X at 4, I'm asking you for the slope over here. So I'm looking for the slope of the inverse function at 4. So I'm telling you that in order to find it, you need to first find F prime. Notice I have not found the inverse function. I didn't find the inverse function, but I can tell you what its derivative is. I didn't find the inverse function, but I can tell you its derivative. So the first thing I need to do is take the derivative of the original function. That gives me 5x to the 4th. Now find F prime at 1. That gives me 5. So I found the derivative of the original function and found its slope. So its slope going through this point is 5. So its slope going through this point is 5. So it's some line, some really steep line going through here. Well, then that tells me that the slope going through the other points is 1 over that. So what that says to me is then if to find the derivative with respect to x of the inverse function at 4, it is just 1 over F prime at 1. So I can find the derivative or find the slope of the inverse function at f of a at f of a. This thing is equal to 1 over the slope of f at a. So my function was x to the 5th plus 3. Very steep function I found. And so what I did was I looked at the point 1,4 on the curve. So I said I can find the derivative at 1. If I take the reciprocal of that, that becomes the derivative of the inverse function at 4. Okay. All right. Now I'm going to give you something you just have to remember. All right, so these are the rules. Okay. So derivatives of inverse trig functions. All right, here we go. So the derivative with respect to x of the sine of x, sine inverse of x, is 1 divided by the square root of 1 minus x squared. And the derivative with respect to x of the cosine inverse of x is -1 over the square root of 1 minus x squared. Okay, so the good thing is the derivatives of cos are just like before. They're just negative. Okay, the derivative with respect to x of the tan inverse of x is simply 1 over 1 plus x squared. And the derivative with respect to x of the cotangent of x is -1 over 1 plus x squared. And then the derivative with respect to x of the secant of inverse of x is 1 divided by the absolute value of x times the square root of x squared minus 1. And the derivative with respect to x of the cosecant inverse of x is -1 divided by the absolute value of x times the square root of x squared minus 1. Okay, that's how you do it. All right, so can't just give you that without giving you an example. Let's do a product rule. So f of x is x squared times the tan inverse of x, then f prime of x, the derivative of the first, which is 2x, times the second, tan inverse of x, plus the first, which is x squared, times the derivative of the second, which is 1 over 1 plus x squared. So I get 2x, the tan inverse of x, plus x squared over 1 plus x squared. F of x equal to the sine of x times the sine inverse of x. And f prime of x is the derivative of the first, that's cosine of x, times the sine inverse of x, plus the sine inverse of x, plus the sine of x, times the derivative of the sine inverse of x, which is 1 over the square root of 1 minus x squared. Okay. All right. So say u is a function of x. Then we need to invoke chain rule. All right. So that would say that the derivative with respect to x of the sine of a function of x, sine inverse of u of x, well, we would get 1 over the square root of 1 minus u squared, but then we have to multiply by chain rule du dx. So f of x is the sine inverse of 3x squared. Okay. So here u, 3x squared, and du dx, 6x. So therefore f prime of x says take the derivative with the u in it. So that's going to give me 1 divided by 1 minus u squared, which is 3x squared. But now I have to multiply by du dx, so I get 6x. So this is 6x divided by 1 minus 9x to the 4th. And the same is true for all the rest of them. Derivative with respect to x of the cosine of u of x is -1 divided by the square root of 1 minus u squared times du dx. Okay, you guys with me? I know this is a lot. We're just getting started. This is cosine inverse. Secant inverse of u of x so I got to remember the derivative of the secant. Well, let's do I think it should be tangent next. So the derivative of tangent is 1 over 1 plus x squared. So therefore, I'm going to get 1 over 1 plus u squared, and then I'm going to have to multiply by du dx. Okay, so we have 3 minutes. Let's give you a nice toughie. It's not going to be too hard. Tan inverse of 4x divided by x plus 1. Let's do x squared plus 1. Okay. So f prime of x is going to be x squared plus 1 times the derivative of tan inverse. So the derivative of the tan inverse is going to give me 1 over 1 plus 4x squared. But chain rule says multiply by what's inside. So that's going to give me a 4. minus the top, which is the tan inverse of 4x times the derivative of the bottom, which is 2x. And then that whole thing is over x squared plus 1 squared. Okay, so the first piece was the bottom times the, I know you guys may have heard low d high minus high d low over low low. Bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared. I don't care how you figured it out, but this is the bottom. This right here, this whole thing in yellow is the derivative with respect to x of the tan inverse of 4x. Says take 1 over 1 plus 4x squared and then multiply by the derivative, which is 4. So that's that whole piece. So you get the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, any questions about that? All right, so some practice. Well, you guys have homework on this, but I can send you some other practice problems so that you can feel that you can work on it, or we can, actually we have recitation tomorrow, so we'll do some practice problems tomorrow. Okay. All righty. Are there any questions?